Hello. In this presentation, we will introduce our paper titled NBDI, a simple and effective termination condition for skill extraction from task-agnostic demonstrations. Recently, notable progress has been made in skill-based RL models, showing promising results in complex environments and robot manipulations. However, the use of fixed-length skills and the absence of appropriate termination conditions often restrict them from making decisions at critical decision points, for example, at crossroads, which can result in significant loss in performance. While maximizing skill length is advantageous in terms of temporal abstraction, extended skills can result in suboptimal behavior, especially when the skills are derived from task-agnostic trajectories. Such suboptimality of extended skills or options can be theoretically quantified using the termination improvement theorem. More details are explained in our paper. In this paper, we propose to use state action novelty to identify critical decision points for skill termination, which leads to the execution of variable length skills. In particular, we use intrinsic curiosity module ICM as our state action novelty estimator. While ICM is typically recognized for providing intrinsic motivation signals to drive exploration in online RL, we found it to be an effective state action novelty estimator when it is pre-trained with offline trajectory datasets. Since ICM takes in state action pair to predict next state representation, it would have high prediction error for sparse state action pairs in the offline dataset. The figure below illustrates the prediction error of state action pairs from 25 randomly selected trajectories within the offline trajectory dataset used for training ICM. We visualized the state of the state action pairs with high prediction error as A, B, C, and low prediction error as D, E, F in maze and block stacking environment. It can be seen that high prediction error can be typically seen in states where we have multitude of plausible actions like A, C, or rare state configuration like B. On the other hand, low prediction error can be seen in states where we do not have any of these properties like D, E, F. When the agent encounters a maze with an unseen goal, it would have no way of knowing which direction would lead to the goal. Therefore, encouraging the agent to make more decisions at such crossroads would effectively connect different areas within the maze, ultimately promoting exploration. In experiments, we show that in both the robot manipulation tasks and navigation tasks, executing terminated skills through state action novelty facilitates convergence toward a more effective policy. The figure left shows that while it appears that on state novelty, solely based on state novelty doesn't lead to better performance, combining it with condition action novelty, which results in state action novelty, leads to better exploration and better convergence. Furthermore, we compare the performance of NBDI to other variable length skills extraction methods in the maze and kitchen environment in the figure right. NBDI's high performance compared to these baseline methods illustrates the need for a more effective termination condition for skill models in solving such challenging long horizon tasks. The figure here compares the decision points made by fixed skill approach and NBDI in the maze environment. While the fixed skill approach agent makes decisions in random states, our model tends to make decisions in crossroads or states that are unfamiliar. For instance, in the lower right area of the maze, the fixed length skill agent shows periodic skill termination due to its fixed length of skills, whereas our approach tends to make decisions in states characterized by high condition action novelty or state novelty. Thank you for listening.